Welcome to Romeo Maths and Science class. Today we want to look at the topic sequence and series in mathematics. We have two types of sequence and series. We have what we call arithmetical progression, which we can call it linear sequence, and we have what we call geometrical progression, which we can call it exponential sequence. But today we'll be focusing on arithmetical progression. Let us look at some formulas that we can use in arithmetical progression. Number one, we have a formula un equal to a plus n minus 1 multiplying d. We also have L equal to a plus n minus 1 multiplying d. And we have Sn equal to n over 2 multiplying 2a plus n minus 1 multiplying d. And the last one, we have Sn equal to n over 2 multiplying a plus what? L, as you can see. So these are some few formulas that we are going to make use of in this topic of discussion. Let us define some of the terms in these formulas. We have our A, which represents what we call the first term of the sequence. We have our N, which represents the number of terms in the sequence. And we have D, all right? Our D represents what we call the common difference, all right, of the sequence. And we have our L, which represents the last term, all right, of the sequence. Now, let us look at some example here. Let's assume I have 2, 4, 6, 8. All right, in sequence, the first number that starts the sequence, we call it first term. And this first term is represented by A, all right? And we can give it a code like U1. So we say our first term is 2, our second term is 4, our third term is what? 6, and our fourth term is what? 8. I can ask you to find, let's say, the 10th term, all right? The 10th term of this sequence of numbers you can see on the board. What would the 10th number be, all right? Now, in sequence, anytime we are looking for what? The number of terms in a sequence. And to be precise, arithmetical progression, we use the general formula, which is our un equal to a plus n minus 1 multiplying d. So with these numbers given, where I'm looking for the 10th number, it means that in the formula, our n will be 10, all right? And our 2 here will be our a, so a will be 2. And we go for the common difference. The common difference is the difference between this set of numbers. And we could see that the difference between these numbers will be 2, as we can see. How do we get the 2? We subtract this preceding term from the succeeding term. So 2 from 4 will give us 2. 4 from 6 will give us 2. 6 from 8 will give us 2, and so forth and so on. So our common difference here is 2. We fix these numbers into the formula, and we'll see what our 10th term will be, all right, as you can see here. So we have this, that is 2 plus, here we have 9 multiplying 2, as you can see here. So we have 2 plus 18, which will give us 20. So it means that the 10th term of this sequence you see on the board is going to be what? 20. So this is how we can use this formula. We use it to find the number of what? Terms in arithmetical progression. All right, let's assume I have the same number, which is 2, 4, 6, all right? And let's say I put 18 here, as we can see here. What can we do? When we have a question like this, and I ask you to find the number of terms, which term will you reach? If this is first term, second term, third term, which term will you reach before you arrive at what? 18. What formula are you going to use? we are going to use this formula. L equal to A plus n minus 1 multiplying D. All right. Now, with this formula, our 18 is the last term. So our 18 represents our L. Our A represents the first number as we can see here, which is 2. And our common difference is going to be what? 2, as we can see. The N is what we are looking for. So we fix these numbers into the formula. So we have 18 equal to 2 here plus n minus 1 multiplying 2. All right. So we are going to have 18. All right, 2 plus this will multiply this, that is 2n. This will multiply this, that will be minus 2, as we can see. So we are going to have 18 here. 2 minus 2 is 0. So we have 2n, as we can see here. We divide here by 2, here by 2. Therefore, n is going to be what? 9. So it means that the ninth number will give us what? 18. And this is how we can use this formula to answer questions in arithmetical progression. All right, let's proceed and see. Let's assume I have 2, 4, 6, 8. And I ask you, what will be the sum of the first 3 terms, as you see here? Now, in mathematics, sum means addition. So if I ask what will be the sum, a student can say that, okay, 2 plus 4 plus 6, and it's going to give us what? 12, which is correct. But what about if I ask you what will be the sum of the 50th term of this sequence? You could see that the numbers is going to be long, and we can't add. Therefore, we need a formula. So mathematically, we were able to generate this formula. Okay, it's a proven formula in sequence, that is AP, that we use to calculate for what? The sum, as you can see on the board. Now, let us use this formula and see whether we are going to arrive at the 12. Now, we are looking for the sum of the first 3 terms. So, with the formula, our n is going to be 3. All right. We have our A here is going to be 2, as we can see. And our common difference is also going to be what? 2. All right, as we can see. So we have 2. Let us fix them into the formula. So the sum of the first 3 terms will be equal to 3 over 2. All right, nicely. 3 over 2 multiplying 2 multiplying A. The 2 here is constant. All right, but our A is also 2 plus our 3 minus 1 multiplying the common difference, which is also what? 2, as you can see. So the sum of the first 3 terms will be equal to 3 over 2. Nicely. We have 4 here. 3 minus 1 will give us 2. 2 times 2 will give us 4. So multiplying 4, as we can see here. All right. So the sum of the first 3 terms, that is 3 over 2 multiplying 8. And 3 over 2 times 8 is going to give us what? 12. So we can see that we arrive at what? 12. So this formula is used to find the sum of what? Sequence in arithmetical progression. Let us also look at this. Let's assume I have 1, 2, 3. All right. Then I have, let's say, 15 here. Now, and I ask you, what will be the sum of this sequence on the board? Now, what will be the sum? We have not been given whether we are looking for the sum of the second, third, fourth, fifth, or 13th, or whatever. But we have been asked what will be the sum. Therefore, first of all, we need to find our n. And how can we get our n? We need to use this formula. So we can combine 2 formulas. Don't forget, we can combine 2 formulas to solve one question. All right. So here our L is the last term. So we have 15 here. Our first term is 1. N we don't know. All right. And our D will be what? 1, as we can see, the common difference here. So we have 15 here, 1 plus, when we use the 1 to multiply this, we are going to get n minus what? 1. Therefore, our 15 will be equal to what? N. We can say n equal to what? 15. So now that we were able to solve for our n, we can now find the sum now. Because now we know that our n is what? 15. So what will be the sum? It will be the sum of the 15th term. What formula can we use? We are going to use this formula. That is xn equal to n over 2 multiplying a plus what? L, as we can see on the board. So we have x, the sum of the 15th term, 15 over 2, multiplying our first term is what? 1, all right? Last term is what? 15, as you can see on the board nicely. So the sum of the first 15th term will be 15 over 2 multiplying 16. And when we multiply this, we are going to have 120, as we can see. So this is how we can use these formulas to explain the concept of arithmetical progression in sequence and series. Don't forget that there will be examples for you to try again with these formulas. Thank you. Let's see how we can solve these questions with the knowledge that we had about arithmetical progression. Thank you.